Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tear, where this is my next video on my feature on the Math Lovers book, which I've been doing for a couple weeks. And I'm up to chapter 2 of volume 1. I'm not going to go over the Math Lovers book anymore. You guys can check it out. Some of my earlier videos about it. Suffice it to say, it is a 3 volume series I wrote from 2019 to 2022, and you can buy it on Amazon.com if you're interested, or you can buy any one of these books. Anyway, let me just start with today's video. Today I'm going to talk about Mersenne primes, which is a very important class of prime numbers. I've been talking about prime numbers for the last week or so. And so anyway, let's begin. So what are Mersenne primes? Well, Mersenne primes are a very important class of prime numbers. Specifically, they're prime numbers that are equal to a power of 2 minus 1. They all have the form 2 to the p minus 1. And it turns out that p has to be prime itself. The exponent has to be prime itself in order for the number to be prime. But that's a necessary condition, but not a sufficient condition. It works, I think, for the first 4 primes. 2 squared minus 1 is 3. 2 cubed minus 1 is 7. 2 to the 5th minus 1 is 31. 2 to the 7th minus 1 is 127. Those are all prime. So you might think that for every other prime exponent, there's still prime, but that's not true. The next case fails. 2 to the 11th minus 1. That's 2047. That turns out to be composite. It's equal to 23 times 89. As a matter of fact, most Mersenne numbers with prime exponents are composite. The ones that are prime are pretty rare. But there are 52 that are currently known. And the largest known, and I think the big reason why Mersenne primes are so important. There's a couple reasons, but probably the biggest reason, for one thing, there's a very fast primality test for testing Mersenne primes. It was discovered by very famous 19th century French mathematician Edouard Lucas, the same Lucas who discovered Lucas numbers, which are kind of like cousins of Fibonacci numbers. But another thing he discovered, and probably even more important discovery he made, was he discovered a test, a very efficient test for testing Mersenne numbers to see if they're prime or not. And since the test is so efficient, so fast, it's been used to calculate the largest known primes to date. I think that something like the 10 largest known primes are all Mersenne primes. And for most of the computer age, even most of human history, I think the largest known prime has been a Mersenne prime. I think there's only been six times in the last, I don't know, maybe 2,000 years since primes were known, where the largest known prime was not a Mersenne prime. I think the last time that happened was from 1989 to 1992 when there was a big gap in the known Mersenne primes. And finally, there was a Mersenne prime discovered in 1992 that was the largest known prime that was a lot bigger than the previous one. And that's happened a couple other times. I think the only time in the computer age that happened before was in 1951. 1951 and 1952, the largest known prime was also not a Mersenne prime because it was another big gap. But anyway, enough of that. So now I just want to show you lists of the known Mersenne primes and when they were discovered. And it turns out that it was only the first 12 Mersenne primes that were discovered before the computer age. Because these things get really big really fast. And for a long time, I think for 68 years, the largest known prime was a Mersenne prime. It was a 2 to the 127th minus 1. This was discovered by Edouard Lucas in 1876. It's the 12th number on this list. It has 39 digits. For a very long time, that was the largest prime number that was known. And it's pretty remarkable that such a large number was known back in the 19th century because, we couldn't factor numbers that large at that time. And we didn't have an efficient primality test for number or arbitrary numbers that large. So this was all for a long time the largest prime number that we were capable of determining if it was prime. But we had to wait for computers before we could find bigger ones. And once we had computers, the largest known prime, the size of the largest known prime, just started skyrocketing. And I think you can see that on this table. I mean, the 13th Mersenne prime was 2 to the 521 minus 1. This one had something like 150 digits. I don't say how many digits these. Oh, I think I do. Yeah, it had, what was that? I have to look at it carefully. 157 digits. There was actually a computer scientist named Robinson who discovered the next five, all in the same year, 1952. I guess that was kind of a banner year for computers because computers were brand new. We were doing them to do some calculations we'd never been able to do by hand before, including, finding like 2,000 digits of pi, but anyway, then there were other mathematicians discovered even bigger ones. And this table here only shows the first 20. I think the 20th was discovered in 1961. And then, we just kept going. I mean, and they've gotten bigger and bigger. And I'd say the last 20 or so of these primes was found on the internet. There's a thing called GIMPS, the Great Internet Mersenne Prime Search. And this has allowed, just amateur people had been looking for primes. I mean, anybody can pretty much download the program for searching for large primes. And I even did this myself. I'm going to get to my own horn a little bit. I never discovered any Mersenne primes, but about 20 years ago, I discovered, I think, 37 large primes. They weren't the largest that were known, but they were significantly large, and they made the top 5,000 list. Another thing I think I should mention is that there's a thing on the web called the Prime Pages that lists the 5,000 largest known primes. And I had 37, a total of 37 primes that I discovered myself that made their list at one point. None of them are in the top 5,000 anymore. I think the largest one that I discovered is like number 20,000 or something. And it has like 60,000 digits. The largest prime ever discovered has about 60,000 digits. It's what's known as a Proth prime. And there's also a pretty fast algorithm for testing Proth primes. Not as fast as Mersenne primes, but I discovered, like I said, 37 Proth primes, and there's another type of prime that's closely related to Proth primes. I may as well tell you what those are. Proth primes are numbers that form k times 2 to the n minus 1, where k is a smallish odd number. And there's also primes that form k times 2 to the n plus 1. I discovered a few of those as well. So anyway, that's what I discovered. But the largest number on this list, this was the largest known prime, I think, from 2018 until just a few months ago. This number had, I think, almost 25 million digits. And the exponents, I think, in the about 82 million. I don't want to read it off, but this was the largest known prime. Was a Mersenne prime. Like most of the time, the largest known prime is a Mersenne prime. But actually, just recently got beaten. Now, this is the largest known prime. This was discovered in October, just about 5 months ago. This is the largest prime that's currently known, 2 to the 136,279,841 minus 1. I think it has something like 40 million digits. And if you wrote this down, I think it would take about 40 books, 40 standard size books, just to write this number down. A huge number. I mean, the largest known primes are getting bigger and bigger, and it's almost not even worth it to write them down anymore. I think the only reason we write them down is just to kind of show off. And I actually had a poster about 20 years ago that had the largest known prime written out on this poster, and the writing was so small you had to use a magnifying glass to read it. And this was a standard size poster, and this was about 20 years ago when I think the size of this prime, I don't remember which one it was, but I think the exponent was something like 1 million something. I think it might have been 1,000,000 to 257,787, which is the 34th largest. So this was like 20 years ago, and I had a poster with that number, and you couldn't even see the number on the poster. So imagine how big this number is. This is about 100 times as many digits. So these numbers are huge. And, I just want to say one more thing. I mean, there's a couple more things I could say about Mersenne primes. Another reason why I'm interested in Mersenne primes, it turns out they're very closely related to perfect numbers. Every perfect number can be found very easily in terms of a Mersenne prime. I'm not going to get into that. I am going to do a video on a few days on perfect numbers, so you'll see me doing that in that video. But this prime, like all other Mersenne primes, gives rise to another really large perfect number. As a matter of fact, the related perfect number has about twice as many digits. So the largest perfect number that's currently known has about 80 million digits. Perfect numbers, in case you don't know, are numbers whose non-trivial factors add up to the number themselves. And just like there's only 52 known Mersenne primes, there's also only 52 known perfect numbers, the largest of which has about 80 million digits. So anyway, perfect numbers are rare too, just as rare as Mersenne primes. But anyway, that concludes my video for today on Mersenne primes. Thank you for watching. Long live math, and I'll see you guys next time. Bye.